Hello and welcome to today's video. In this video we'll be going over every single function you can use on a string. If you are looking for a specific function, please look in the description as every function is in there along with a timestamp in the video. Most of all the commands being used today will be using the variable string which is set to hello and welcome to Python. All of them will be structured string dot and then the function. Alright, so let's begin. First of all, we are looking at underscore underscore add underscore underscore. For strings, this command will add on to the end of the string that you've placed into the brackets. So for this example, we want to add added on, which gives us the result, hello and welcome to Python added on. Next up is underscore underscore contains underscore underscore. This will return true if the string you have placed in the bracket is in the variable you have given, and will return false if not. For this example, hello is inside of the string, so it returns true, but goodbye is not, so it returns false. The next is underscore underscore get item underscore underscore. This will go through the string starting from 0, so 0 will be H and 1 will be E, and so on. And we'll see which value is at the number you have given. So for this example we have put 2, so the letter L is at that position, so that is what is printed. The next command is underscore underscore len underscore underscore. This will return the length of the string that you have given, so the length of our string is 28. Now on to underscore underscore mul underscore underscore. This will return the string for the number that was given, so we have put 4 in. So it will print the string 4 times. Now on to capitalise. This will make all the letters in the string lowercase and make the first letter a capital. If it's not a letter at the first value, it will just turn everything lowercase and leave the first character the same. Next is casefold. This turns all the uppercase letters into lowercase. Next up is centre. This will place your string in the centre of a given range, so if the range you give is 50, then it will place your string where it would be if we wanted bang in the middle of there. Now on to count. This will just count how many times a given value is repeated in your string. So if I wanted to count how many O's are in the string, it will come back with 4. Next we have endswith. This will return true if what we put into the bracket is the same as what is at the end of the string. It will return false if not. So in my example, an exclamation mark is at the end of my string, so it returns true, but the letter G is not, so therefore it returns false. Next up is using expanding tabs. For this command, I will be using a different string. This one is the same, but I have added a tab into it using \t. So we can see what it looks like when I print it normally. But then I can use the function to set the size of the tab to how many white spaces I would like, so I've set it to 10. And you can see that it makes it slightly larger than what it was. Now we are using find. This will find and return where the value that was given is in the string first. If it is not in the string, then it will return -1. So for my examples, I am looking for n in my string. The first instance of n is at location 7, so that is what is returned. For this next command, format, I am once again not using the original string. I am now using this string, my favourite pet is A. And then in curly brackets I've put pet underscore name. Next up I use the function, and then inside brackets I put the name that I put inside the curly brackets, pet underscore name, equals, and then what I want to set the value to. In this it is a dog, therefore this prints my favourite pet is a dog. Next up is similar, but I've replaced the names with 0 and 1. This is a different way of using format. Now we can just put the strings in and they will find their place. So this time it prints my favourite pet is a dog, then a cat. Alright, now we've got index. This will find and return the location of the given string. If it is not in there, then it will cause an error. Unlike find, which returns -1. So in this example it finds that the first instance of L is at location 2. Now on to the next one, isalnum. This returns true if all the values in the string are either letters or numbers. If one or more values are not one of those two given things, it will return false. So you can see that the first string has an exclamation mark at the end and spaces throughout, leading the function to return false. But the second string I've removed the exclamation mark and spaces and placed some numbers in there as well, and it has returned true. Next will be isalpha. This will return true if all the values in the string are letters. If not, it will return false. So my first example shows that there is not just letters in the string, so it returns false. However, on the second string I have removed the spaces and the exclamation mark at the end. This makes the function return true. Next up is isascii. This returns true as long as every character in the string can be found in ASCII code. Things that are not in ASCII are generally stuff of foreign alphabets, so accents on letters or Greek letters and so on. Now we have isdecimal. This will return true if all the characters are numbers. If not, it will return false. So our first example, there is no numbers at all, so it returns false. But the second example is only numbers, so it returns true. Next up we have isdigit. This returns true if all the values in the string are digits. So this means they are either decimals, superscripts or subscripts. So for this example, it returns true since all our values in the string are decimals. Next we have isidentifier. It will return true if the string is an identifier. My example shows false, but the rules for an identifier is it doesn't contain spaces, it doesn't start with a number, and it is made out of only letters, numbers and underscores. For the next function we have islower. This will check that every value in the string is lowercase. If so, it will return true. If not, then it will return false. So for our first example, our regular string leaves it to return false, but then I have made a string that contains only lowercase values. So now when we run this string through the function, it returns true. Next up is isnumeric. This returns true if all the values given are numeric, so this will be including fractions, numbers, 0 to 9 and exponentials. So this example shows it will return true. Isprintable. This returns true if all the characters in the string are printable. Most of the time this will be true, but some things will return a false result. For example, backslash commands like \n will print false since the \n itself will not print. All of the string will print, so therefore our result is true. Next up is isspace. This will return true if the string is only white spaces. If not, it shall return false. So for the original string, there are letters and others, not just white spaces, so then it returns false. But once I just put spaces through the function, it returns true. Next up, we will be using istitle. This checks if all the words in this string start with a capital letter, making it a title. So our original string does not classify as a title, so it returns false. But then we have this new string where I've changed all the words to start with a capital letter. This returns true as it is a title. Following, we will be using isupper. This is the opposite of islower. If all the characters in the string are uppercase, then it will return true. If not, then it will return false. For this example, my original string will return false as there is a lowercase character in the string. However, on the second string, I have made it all uppercase, therefore returning true. Next up is join. The string that you place into the brackets will place the first character in, then print the string, then put the second character in, then print the string again, and then repeat until we get to the last character. Now let me show you an example. As you can see, we get H, hello and welcome to Python, E, hello and welcome to Python, L, hello and welcome to Python, L, hello and welcome to Python, O. Now we have ljust. This command will set the width of the string and fill the right side of any remaining with either white spaces or a given string. So for this example, I have set the width of the string to 35 and then put the filler to be the letter L. So therefore, in the result, the string gets printed and then L's are placed until it reaches the width given of 35. So since our string is 28 long, it places 7 L's in front. Next up, we'll be looking at lower. This function makes all the characters in the string lowercase. So when you look at the example, it gives us the string but with no uppercase letters as they have been changed to lowercase. Next we have lstrip. This will remove the given string from the left side of the string. So in our case, I'll be stripping hello from the left side of the string, therefore leaving and welcome to Python. If what you place in the brackets isn't on the left side of the string, it won't do anything. Now on to maketrans. This makes a translation table that you can use to encrypt and decrypt code. The easiest way to do this is to write two strings in the brackets. One is all the characters you want to find, and the second is what they will be replaced by. This will then print out a translation table for this. So in this example, all O's will become H, all H's will become O's, all Y's will become T, and all E's will become 4. Then it prints out this translation table. You can then use this on function translate, which I'll be showing later. Next up is partition. Partition will create a 3-part list. It will find the first instance of the string that you have placed in the brackets, then create a list with what it was before it, the partition, and then what is after it. So on my example, I am parting a capital P, so therefore it returns hello and welcome to, then the capital P is the next part, and then the rest of the string. Now on to removeprefix. This will remove what you place in the brackets from the start of the string. So in my example, I have put hell, so it removes the hell part of hello and leaves us with O and welcome to Python. Next we have removesuffix. This will remove what you place in the brackets from the end of the string. So in my example, I have fon. This will leave us with hello and welcome to Pi. Next we have replace. This will replace the first string with the second string. So in my example, I will be replacing any O's with T's, which leaves this string printed. Next is rfind. This is exact same as find, but instead it will search from the right side instead of from the start. So therefore, in our example, we are looking for the first O. If we were going right to left in the string, this would be at 25. If the letter you place in is not in the string, then it will return -1. Next up is very similar. It is rIndex. This is the exact same as rfind, but if the letter isn't in the string, it will cause an error. It will go from right to left through the string and return the location of the given string. Normal index will go through the string from left to right. In our example, we are looking for T. The first instance of T, starting from the end, is at position 23. So that is what is printed. Next up is rjust. In this, we start by specifying how wide we would like the string to be, and then we have the option of leaving it plain, or you can place in the string what we would like to use as the filler. So in this example, we have set the width to 40. Now, because we have left it blank, from there it has placed 12 spaces before it. This is because the length of our string is 28, so to make it 40, we place 12 white spaces before it. If we didn't leave it blank, instead of white spaces, it will be the character instead. Now on to rpartition. This will create a 3-part list, going through the list from right to left. It will print the first instance that you've placed in the brackets, then create a list with what was before it, the partition, and then what is after it. So on my example, I am parting O, so therefore it returns hello and welcome to Pyth, then the O as the next part, and then the rest of the string, N, exclamation mark. This is different to partition because partition you go through it from left to right instead of right to left. Next up is rstrip. This will remove whatever you put into the brackets from the end of the string. So for my example, I've put on into the bracket, so this removes it from the end and leaves us with hello and welcome to Pyth. Next we have split. This can be used to create a list from the string, and each attribute is split up by what you put into the bracket. You can optionally put a number afterwards. This will be the maximum split, so this number will stop splitting once you have reached it. Now on to the example. My example is splitting every time E appears. This leaves us with this list. For this next function, we'll be using a different string. So instead of spaces, we have placed in a new line. This is because we are using the function splitlines. This will separate every line into a list. So in this example, every word is placed into its own part of the list. Next we have startswith. This will return true if the value you give is the value at the start of the string. If not, it will return false. So for the example, we've first checked to see if capital H is at the start, which it is, so it returns true. However, F is not, so it returns false for that one. Next up is swapcase. This will change all the uppercase letters lowercase and all the lowercase letters uppercase, as you can see from this example. Next up is title. This will identify all the start of the words in a string and will make the first letter of each word uppercase. This is the example, and you can now see that the A in and is now capital, as well as the T in to. Now we have translate. This will encrypt or decrypt a string given a translation table. You can make a translation table from using maketrans, which was earlier in the video. So for this, the translation table will swap O out for H and H out for O. So therefore, this is the string that remains. Now we have upper. This will make all the characters in the string uppercase. So as you can see from the example, the string is all now uppercase. Finally, we have zfill. This takes the width that you want the string to be and places zeros before the string until it is that width. So for this example, we want the width to be 36. The length of the string is 28, so therefore it places 8 zeros before the string. Now that is it for the video. I do really hope you have learnt something from this video, and I hope to see you again soon.